Okay, so today we are looking at graphing general rational functions. So these are a little more complex than the ones that we did before where everything was linear. So we have f of x equals p of x over q of x. And we can have any polynomial in the numerator or the denominator. So it could be a cubic, a quartic, any of those things. So the X-intercepts of the graph will be zeros of the numerator. Vertical asymptotes are zeros of the denominator. To find the horizontal asymptotes, we'll divide the coefficients of the largest degree. So three options there. Y equals 0 divided by b. We're going to get a horizontal asymptote of y equals 0. We have y equals a divided by b. We get y equals a number. If we have y equals a divided by 0, it's no horizontal asymptote. That's actually going to be a slant asymptote or an oblique asymptote, which is something we'll get into in pre-calculus. I will show you where that comes into play. So, and when I say 0 divided by b, a divided by b, and a divided by 0, if you think of the numerator having, so if the degree of the numerator is smaller than the degree of the denominator, like we have an x squared over an x cubed. That's when you would have 0 divided by b, because there's 0 x cubes on top, and then there's some number of x cubes on the bottom. So that's this first option, where numerator degree is less than denominator degree. The second one is where they're the same. So same thing here, they're equal. So if you have some number x to the third over some number x to the third, you would divide that a divided by b. The last one is where the numerator is bigger in degree than the denominator. So you have so many x to the thirds divided by something x squared. So you have 0 x to the thirds on the bottom. That's what you're looking for. So let's go through this on an example here. So graph the following by finding the intercepts, the asymptotes, relative max and mins we can find using graphing calculator, and then state the domain and range in interval notation. So first off, let's find the x-intercepts. So the x-intercept we said would be where the numerator is 0. So if we plug in 0 for x, or if we set the numerator equal to 0, we get x equals 0. So if we plug x in as 0, we get 0 back out, which means that your y-intercept is also 0, 0. To find your y-intercept, you plug in 0 for y, solve. But vertical asymptote then is where the denominator is equal to 0. So where is x squared plus 1 equal to 0? Well, subtract 1 from both sides. X squared equals -1. We know that's going to give us an imaginary number. So this is our vertical asymptotes. So there's no vertical asymptote because there's no real number that we could get for x there. So horizontal asymptote, we're looking for the largest degree. So the largest degree I see is x squared. How many x squareds do I have in the numerator? Well, none. How many x squareds do I have in the denominator? The coefficient in front of there is 1. So then I get 0 divided by 1 is 0. So my horizontal asymptote is going to be at y equals 0. So then I know my x-intercept, my y-intercept is at 0, 0. So that's a really interesting thing that you see we are on that horizontal asymptote. And so we've talked a lot about how you can never cross a vertical asymptote. You can cross a horizontal asymptote. You don't see it a ton, but it does happen. The asymptote, remember, is where we are approaching. So we should see it approaching that line, that asymptote on the x-axis on this graph. So I'm going to pick a couple points. I'm going to pick 1, 2, and I'll pick -1 and -2. So opposite sides of that x-intercept, y-intercept is probably a pretty good bet for this one. So if I plug in 1, 1 divided by 1 squared plus 1 is 1/2. If I plug in 2, 2 divided by 2 squared is 4, plus 1 is 5, so 4/5. -1, -1 divided by -1 squared is 1, plus 1 is 2, so I get -1/2. -2 divided by 2 squared plus 1, -2 squared plus 1, 4 plus 1 is 5, so I get -2/5. This actually should be 2/5, not 4/5. 2 divided by 2 squared plus 1. Okay, so then I can plot those over 1 up 1/2. And over 2 up 2/5. Left 1 down 1/2. Left 2 down 2/5. So then to find the relative max and mins, go into your graphing calculator and type this in, and you're going to go and find the maximum point and the minimum point at each of those spots. So go ahead and take a second to do that. When I plug that into my calculator, I found that the relative max and mins were my 1, 1/2, and -1, -1/2. So that's the highest point this graph hits before it goes back and levels out and heads toward that asymptote. And then -1/2 is the lowest point that graph hits. So it stays very close there. It just pops up to 1/2 and down to -1/2 before going along that axis. All right, let's look at another one of these examples. So we're going to find intercepts, asymptotes, points, and relative max and mins here. So let's see if we want to find the x-intercept. We want to know where 2x to the third is going to be equal to 0. Well, x would be 0. If I plug in 0 for x, I also get 0 for y. So vertical asymptote is where the denominator is equal to 0. So x cubed minus 1 is equal to 0. Add 1. So the cubed root of 1 happens to be 1. So x equals 1 will be our vertical asymptote. Horizontal asymptote. My largest degree is 3. So how many x to the thirds do I have on top? I have 2. How many on the bottom? 1. So 2 divided by 1 equals 2. So horizontal asymptote at 2. I'm going to go ahead and plot both of those. So vertical asymptote at x equals 1. horizontal asymptote at y equals 2. This looks to me like it's going to be a typical hyperbola when I type it into my graphing calculator, so there's not going to be a relative maximum or minimum then. We're going to just have our hyperbola in those quadrants. So I'm going to pick some points here. So I already have 0, 0. That's to the left of the axis, or of the vertical asymptote. So I'm going to pick -1 to plug in. So if I plug in -1, I get -2 times -1 to the third, which is still -1. So I get -2. Then I have -1 minus 1, which is -2. So -2 divided by -2 would be +1. So left 1, up 1. So that's what this branch looks like. So then I need to pick things to the right of that vertical asymptote of 1. So to the right of 1 would be 2. So if I plug in 2, I get 2 to the third is 8. So 8 times 2 is 16. And then I get 2 to the third is 8 minus 1 is 7. So I get 16 over 7. So 16 over 7 is a little over 2. It's 2.286. So 2 and 2.2 is right there. And then if I plug in 3, I get 3 to the third is 27 times 2 is 54. And then I get 3 to the third is 27 minus 1 is 26. So if I reduce that, I get 54 over 26. I get 2.07. So I'm at 3 right here. So very, very close. But that's what that one looks like. One thing we need to do that we didn't do on the last one, so we'll go back and do that one in just a second, is domain and range here on this one. So domain, it looks like I can plug anything in except for our vertical asymptote of x equals 1. So -infinity up to 1, and then 1 to +infinity. For range, it looks like we can get anything out up to 2, and then from 2 up to infinity. Let's go back and take a peek at this one before we move on to our last example. So our domain doesn't look like we have any restrictions. We crossed that horizontal axis, so -infinity to infinity. And then range, we saw that our lowest point was -1/2 and our highest point was 1/2. So that's all we're going to see out of it. We'll never get anything below -1/2 or above 1/2. All right, last example here. So this time we have x squared minus 3x minus 4 on top and x minus 2 on the bottom. So let's see. We want to know for our x-intercept where x squared minus 3x minus 4 is going to be equal to 0. So then I get, I'm going to factor this. So x minus 4, x plus 1 would equal 0. So x equals 4. X equals -1, so those are my x-intercepts, so that's 4, 0, and -1, 0 are my two x-intercepts here. Then my vertical asymptote, I want to know where x minus 2 is equal to 0. Well, x equals 2. Then my horizontal asymptote. I have x squared is my largest degree there, so I have a 1 x squared on top, and I have none on the bottom. So 1 divided by 0, that's undefined if we try to do that. So there's no horizontal asymptote. However, we could have a slant asymptote here, and I'm going to show you how to find that in just a little bit. So I'm going to go ahead and plot these things that I see. So vertical asymptote at x equals 2. And I already have a couple points because I have those x-intercepts. So I have x equals 4. And then I have x equals -1 on the x-axis. So 4, 0, -1, 0. So then let's go ahead and pick out a few more points to help us see what this graph looks like. So to the left of +2, let's see. I'm going to try to pick something that'll come out at least a little nice. Let's go with 1, and then let's go with a -2. Will come out a little nicer. And then 3 and 5. We'll try those to see if those come out okay. So if I plug in 1 squared minus 3 times 1 minus 4, and 1 minus 2 will give me a -1. I get 6 out. And then if I plug in -2, I get -1.5. I plug in 3. 9 minus 9 minus 4. I get -4 over 3 minus 2 is 1, so I get -4. And if I plug in 5, I get 2. So those are pretty nice numbers. So over 1 up 6. -2, -1.5. If I plug in 3, I get -4. If I plug in 5, I get 2. So it looks to me like it's doing this. Now that may not be exact. Domain looks like anything except for +2. So -infinity up to 2, and then 2 to infinity. For range, I don't see any restrictions. It looks like we're going all the way down to -infinity, all the way up to +infinity, and not skipping anything there. Okay. What I want to show you is something that we had talked about in the past, and that is using division, using synthetic division in this case, to find the equation of what that slant asymptote would be. This is extra. This isn't anything you have to know, but it's kind of cool to be able to see. So if I put 2 in the box, that's what I'm dividing, is that x minus 2. I have 1x squared -3x minus 4. So I'm going to bring down 1. So 2 times 1 is 2. -3 plus 2 is -1. And then 2 times -1 is -2. I do get a remainder here, and that's okay. But I'm not going to worry about the remainder. So remember, we drop it down a degree. So this would be y equals 1x minus 1, and then we would have -6 over x minus 2. But we're not going to worry about that. But if I plot that line, x minus 1, so that's a y-intercept of -1. I'm going up 1 over 1, up 1 over 1. You should see that's where this is approaching. So kind of cool to see that extra information, nothing you have to know. but to see that slant asymptote or oblique asymptote when you don't have a horizontal asymptote. All right, guys, that's all I got for you today. If you have questions, come in and see me. Otherwise, I'll see you in class.